In this video, we're going to talk about circulation, so blood supply that goes around the kidneys, because we have a large, remember, about 25% of cardiac output's going to the kidneys, so we have a large amount of blood supply that kind of divides into smaller and smaller pieces. So first, we've learned the renal artery coming off of the aorta is going into the kidneys. And then it branches at the renal sinus. So in this area right here, it's going to branch into two kind of segmental arteries. So you can see just kind of right here is a segmental artery, and here it is. Then they're going to branch into what we call interlobar arteries. So you can see they're going between lobes here, kind of dividing and going into each lobe. And then interlobar arteries come along and branch into arcuate, which run along kind of the base of the renal pyramid that you see here. They are going to be kind of the boundary between the cortex and the renal medulla. And then we're going to see further division coming up from the arcuate arteries. So the arcuate arteries then, so the ones that are running along the kind of base of the pyramids, are going to branch into what we call the cortical radiate arteries. Again, these are going to be in the cortex, so that's the cortical part, and they radiate out like kind of sun rays that you can see here. So all of these little kind of branches here are cortical radiate arteries coming off of the arcuate. The cortical radiate arteries are what giving off, so coming off of them are going to be afferent arterioles. So remember the entrance and then the exit. So we're going to have efferent as well. So afferent arterioles are going to lead to the glomerulus. So each of these little kind of branches right here is an afferent arteriole leading to the glomerulus, which is that tuft capillaries that does filtration. So each one is going to supply a nephron. That's why there's kind of a bunch of branches coming off. So each one of these is an afferent arteriole. Then we have cortical radiate veins. So we're going to go through capillary system. So it's going to have arterial side, and then we're going to have venous side. So cortical radiate veins is going to collect blood from the capillaries of the nephron, and we'll talk about those next, and drain into arcuate veins. So it goes kind of backwards of what we went with arterial supply. The difference is there's no segmental. So arcuate goes to interlobar, which are all of these, but there's no segmental veins. There are only segmental arteries. So all of the interlobar veins drain into the renal vein that goes into the inferior vena cava. So this would be the arcuate right here, cortical radiate veins coming down, going to arcuate, going to interlobar, that then goes into the renal vein. So this is just showing you, so we have the renal artery. We do have segmental arteries that lead to the interlobar, that go to arcuate, that lead to our cortical radiate. Our cortical radiate give off all the afferent arterioles that lead to the glomerulus. And then we have efferent arterioles that are going to go to the capillaries of the nephron. Again, we'll go over those. And then it goes cortical radiate veins, arcuate, interlobar. We skip segmental in the vein section and go right to renal. So again, the afferent arteriole off of the cortical radiate artery supplies blood to each individual nephron, and specifically is going to supply blood to each of the glomerulus. So it's going to go into the glomerulus. So we have an afferent arteriole that leads to the glomerulus, And then we're going to have an efferent arteriole, which is the exit. So you have an entrance and an exit for one-way blood supply. So blood's going to go from the glomerulus. Everything's kind of filtered out. And it's going to go to the capillaries, and it's paratubular capillaries. Paratubular is kind of in the name that they're around the tubules of the nephron. So all of the things that are going to be reabsorbed, so you've gotten rid of them, filtered him here, well then in the paratubular capillaries, we're going to reabsorb them or get rid of more stuff that we need to. So the paratubular capillaries is going to be, again, around the renal tubules. It's surrounded, so when things are added and subtracted to the tubes, they are going to kind of be in the paratubular fluid, which is sort of like the extracellular space. So it collects water and solutes that are reabsorbed from the nephron and can deliver anything that we need to get rid of. So if we need to get rid of them, we'll secrete it into the nephron from the paratubular fluid. So these capillaries are going to be associated with that fluid. So you have the capillaries, you have the paratubular fluid, and then you have the renal tubules. So whether we need to reabsorb and go into the capillaries or secrete and go into the renal tubules. So then the paratubular capillaries are going to drain into those cortical radiate veins and go down the line that we talked about just a second ago. With the juxtamedullary nephron, there's an extra capillary bed. So all the same blood flow, there's still paratubular capillaries like we saw with the cortical nephron, but there's an extra. And it's called the vasa recta. So they are kind of connected to the paratubular capillaries, but they go deep into the medulla where we have our nephron loop. So they are going to run along the nephron loop specifically because it's longer. Remember, the juxtamedullary has a really long nephron loop. So all the rest of the tubules would be up here. And then if we just had paratubular capillaries, they wouldn't go the length of the nephron loop. So we need an extra kind of extension of the capillaries, and that's the vasa recta. So this is going to be, since the nephron loop goes into the medulla, the vasa recta is going to go into the medulla as well. Same thing, drains cortical radiate veins. So we're just showing you, again, this is a cortical nephron, so shorter nephron loop. These is showing you, so right here would be the cortical radiate artery coming off. And then we have the afferent arteriole leads to the glomerulus, that tuft of fenestrated capillaries. And then the exit, E is for exit, so E equals exit, is going to go and then lead to the paratubular capillaries. So all of this kind of capillary system surrounding all the tubes, the proximal convoluted tubule, the distal, and the nephron loop. And then as we're kind of exchanging with the tubular fluid, paratubular fluid, so all the fluid around here, things that are reabsorbed from the renal tubules or secreted into them, then it leads to the cortical radiate vein. So this is showing you a juxtamedullary nephron. So again, we still have the same thing. We have the afferent arteriole leading to the glomerulus, and then we have our efferent arteriole, which is our exit. And then we have paratubular capillaries that are surrounding the distal convoluted tubule and the proximal convoluted tubule. But then we have these long, straight capillaries that are going extension with the really long nephron loop. So those down here is going to be the vasa recta. So again, vasa recta only with juxtamedullary, only associated with the nephron loop, and then it leads to the cortical radiate vein.